actually pretty nice. Yeah, it's really good. This is the photo. It's fast.
It's really good. Some
No, it's really good. Is it Bluetooth or is it 2.4 gigahertz? Kind of connection you're using? Is it infrared? Because all I see is for the laser pointer. Okay. No, really. Nifty. Nifty tool. I'll take good care of it. Thank you. I've been using the laser pointer a lot, so.
Hello, everybody. I'm Jürgen Rauschenbach from DFM Germany, and it's my pleasure to welcome you to this virtual people session. It seems we are running in concurrence to the cloud panel that might attract a lot of people, so we are a little bit less in that session, but that's fine enough. We have three speakers from Slovenia, from Germany, and from Finland. And we start with Rok Papež from Arnes in Slovenia. He will talk about connecting web and Kerberos single sign-on, something that was developed in Arnes. And those of you having been in the TF-EMC Square in Loughborough know already something about it. But anyway, Rok will now go in the details. The floor is yours, please.
Thank you, Jürgen. I'll be talking a bit about the SAML AI system and the Kerberos, and then how to have the hybrid applications that are using both systems and how to make them work together. This is just one of the scenarios how to interoperate different SSO systems, and I hope you'll find it as interesting as I did when we were developing this. But first, I would like to see what the audience probably knows a bit about those technologies. How many of you guys have deployed Kerberos in your organizations, have been using it? Can I see some hands? Kerberos? 1, 2, 3. That's quite some. And how many of you have been using the SAML AI system, like Shibboleth or Simple SAML PHP? Oh, most of you. That's very good. Well, then we can go on to the presentations. First, a bit about the Kerberos system. The Kerberos protocol is primarily an authentication protocol, meaning it's by itself, it doesn't do much in the way of the authorization. It doesn't carry much of the authorization data. Its primary purpose is to do authentication. It is a single sign-on system, meaning that the user is prompted for his credentials only once, and then he can access multiple resources with those credentials. And it's been, its name was derived from the Greek and Roman mythology. I like to interpret the name Kerberos here. It's a three-headed dog guardian. I like to think of it as authentication, authorization, and accounting, each head for every such thing. It was developed during the MIT project Athena, but I think that we can skip the history. It's not that interesting. There are multiple software implementations of Kerberos. You probably have mostly known about the MIT Kerberos, but many of you using the Windows 2000 or later and have deployed Active Directory have probably encountered Kerberos but never knew about it. So, how does actually Kerberos work? We should first look at this protocol to get a bit of the idea how it's working, how to integrate it then with SAML AI. Well, first of all, it's an in-band for different protocols. It works in-band, meaning it's part of the protocol, for example, the IMAP, the POP3, the Telnet, or SSH protocol. Inside, when you connect to this service, you do the GSS Kerberos credential exchange, and this is how you can use these credentials to access different services. It doesn't open a separate port. It doesn't use some kind of back channel. It uses the front channel, the in-band, to send its credentials, its tickets. The Kerberos is using the tickets. The Kerberos uses the third-party trust point, also called the KDC, Key Distribution Center. This is the Kerberos server, as it's usually called. And the core technology used in the Kerberos protocol is symmetric cryptography. We mostly know the asymmetric cryptography used by the X509 certificates. This is the symmetric cryptography, which is much faster, and it's maybe you could say also a bit less secure algorithm-wise, but the speed really brings it as a good point. When the client first tries to use the services, the first thing it has to do is acquire sort of a master ticket. In Kerberos, we're always talking about the tickets. The ticket for this service, the ticket for that service. But the one ticket that's the most important, sort of the master ticket, is the ticket granting ticket. And we'll look at the later slide on the diagram how it can be used. The client to KDC trust is established using a shared secret, a password. It's using actually the symmetric cryptography, which means that the user is prompted for his password, he puts in the password, and he obtains the master ticket. Then when he needs to obtain further tickets, he uses the master ticket to say, well, I would like to have some more tickets, a ticket to the IMAP server, to the SSH server, and he's acquiring those tickets. But he doesn't need to insert, to type in his passwords anymore. Yeah. So here we have the diagram. A user here, he uses, for example, the name userx@org.eu. This would be his username, and this is the Kerberos realm. Together, they form the Kerberos principal names. It's like the eduperson principal name, for example, but it's in the Kerberos context. The user first, number one, needs to access the KDC, Key Distribution Center, acquire the master ticket, and afterwards he can do multiple requests for multiple service tickets. When he has the ticket here, for example, this example shows the service ticket for IMAP server, he can access this service using that ticket. But I think that the best way how to show the way that the Kerberos works is to demonstrate. And I prepared a screencast. Just have a look at it. This we can see a user who is logged into a Unix shell here. And the klist command is used to list all the tickets. Currently, the user typed klist, and you can see that there's no ticket file, meaning this user doesn't have any tickets. And this user is now trying to SSH into this host. What you can see is that because the user here doesn't have the tickets, he is being prompted for his password to access the SSH service. Because the SSH handles simultaneously multiple authentication protocols. One of them is Kerberos, and one of them is the password authentication. The password authentication was selected because the user doesn't have the ticket. Let's have a look at it again. This is the same host, just SSHing to the same host. And what the user now did with the kinit, he requested the ticket granting ticket, the master ticket. Now, the SSH, the PAM stack can be configured for when the user logs in that the master ticket is created on its own. But I wanted to show these steps here separately so that you see how the ticket granting ticket, the master ticket, can be obtained. And here, user typed in the username, kinit. The username was obtained from his user ID. This here is the KDC realm. He was prompted for the password, and let's check if we got any tickets. And yes, here we got the master ticket, the Kerberos ticket granting ticket. Now let's try to do the, to see the details of this ticket. Using the klist command, we can see some of the details. For example, the encryption used, the symmetrical encryption, the validity of the ticket. The ticket is time constrained, meaning it's valid only a couple of hours, or in my case here we can see for 24 hours. But let's try the SSH command now. Okay? So we're going to SSH into the same host again. Voila. So no password prompt. This is the way that the Kerberos works. After you obtain the master ticket, you can access the different services, and just by having the master ticket, the other tickets are automatically obtained by the software. We can look at it. The SSH command obtained the other tickets that were needed. And here we can see this is the ticket that was needed for access to this host. You can, of course, also do it manually. Just request the ticket, the service ticket, and I'm going to request one manually for the IMAP server. Of course, I could have just opened the Thunderbird and accessed the IMAP server. It would work the same way. And here I've got the service ticket, another one. And if I wanted to remove the tickets, I just type kdestroy. So this is essentially the Kerberos in the nutshell. And if we continue, okay. So this is also the cheat sheet, the commands that I used. Okay, Kerberos actually is a pretty good protocol. It works pretty fine, but there are some shortcomings which I believe are mostly responsible for it, that it wasn't so widely deployed in Europe as it was, for example, in the United States where it was developed. First, the documentation is pretty bad, and if you're doing development, you usually browse the source code because it's, I think that the horrible is pretty nice description for it. It also has a questionable security track record, and that's why it's, I think that it's partially blamed because it was always treated from the design up as a LAN or a campus service. It was never meant really to be, from the startup, open as an internet-wide service available to anyone. Of course, you can open it, and there are ways how to even interconnect different Kerberos servers between each other, but it usually is just deployed as a campus technology. The security track record has improved lately quite a lot, especially because there's also the Heimdall implementation of the Kerberos, which has a bit better security record. And also because of the experience and because it is more stable software, widely, it's, especially in the States, widely deployed. But then we look at other things that we are quite interested in. For example, the authorization and the data. It doesn't do that. Kerberos is primarily about this user is who he claims to be. Now it's up to the application to allow him to use the resources or not. Usually the application just checks if the user is present. Does it have the shell account on this machine? If he has, then the entry is allowed, or otherwise it's denied. It can be used also for the web application using a SPNIGO extension, but unfortunately it's limited to local network use, meaning that, for example, in Internet Explorer, if you use that, would like to use the SPNIGO for authentication, it will only work for the local network because of the security settings. And for the Firefox, it also supports SPNIGO. You need to enable it manually. And if you look at the SAML, the distributed AI using SAML, as they call it, and we compare this, well, the SAML AI system is mainly used for web applications to sort of, let's separate from the application the login and the actually data processing or doing something with the application. This is also a single sign-on system, and the user authenticates using this, I would like to use this term, login application. It's the IDP, as we, for those of us who use it a lot, but I like to explain it as it's a login application. We have certain web applications, we take the login module away, put it in a separate web application, and this is the SAML AI, as it could be explained plainly. And the SAML AI system is very much concerned about authorization data. How to send attributes to the application so it can do a better decision about how to allow access of user to the service and how to constrain the user, maybe not even allow him the access. And it's also been around since 2002, where the SAML 1.0 standard was firstly. So it's not a very new technology or something that was made just previous year. Also, the SAML AI, there are some implementations like Shibboleth and Simple SAML PHP. There are more than those, but these are the most popular in our environment. One is a bit older. It's very configurable, but it's based on Java. And the other, the Simple SAML PHP, it's a newer one, but it's extremely easy to use. SAML AI, if we compare it a bit to the Kerberos, it's sort of, we can also again say that it's using some sort of third-party trust point, which can be defined as a metadata distribution point. It's using the asymmetric X509 public key cryptography, but the clients are usually just the web browser. Using the web browser redirects to handles the access to either the login application and to the wave, for example, where you select where you're coming from, and similar. This is the schema that represents how the user accesses a web application. We have the web browser here, and the user, which tries to access the resource, first makes a connection to this web server, and he's denied entry because he doesn't have the appropriate authentication tokens. He's not yet authenticated. He's redirected to the discovery service where he selects where his login application is, where his IDP resides, or which organization he's coming from. He's redirected to the home organization where he authenticates, and the attributes together with the authentication assertion are sent here to the resource, which then sees, okay, this user has logged in. I also have some attribute data about him and can decide to let him access the service and in which way to access the service. I think that we can skip this video demo since most of you have seen, have been using these SAML AI systems already. Excuse me. But let's compare these two technologies together. SAML AI is mostly designed for the web application. It can have different profiles, but currently it's mostly used for this, for the web applications, while Kerberos mostly for non-web applications. One is meant to be used internet-wide, one is most often limited to local or campus networks. One uses the asymmetric keys, one the symmetric keys, one uses SAML, the other ASN.1, which is not really important. And one handles the authorization data, and the other mostly doesn't handle authorization data. And comparing this, really, SAML AI and Kerberos are not competing protocols. They both live in their own problem space, as one could say. When they get together, actually, when is in hybrid web applications. If you have web applications that only deal with user-generated contents, like for example, if you have wiki or if you have sort of discussion boards, things like that, the user comes to the service, to this web application, and he puts in his data, he manages the data, he shares the data with other people. But what if you have a web application that needs to do something on behalf of the user? For example, if it's a webmail and needs to access the IMAP server, and IMAP server doesn't support the SAML AI. The webmail supports SAML AI, but the IMAP does not. But what does the IMAP support is Kerberos. So let's go and look at this picture. I'll give you a minute for the complexity of this picture to settle in. What we have here is a web application. We can say that this is the webmail, and for our example here, this is the IMAP. The user is located here, and he has his eduperson principal name. That's the name used in the SAML AI as a username. And he tries to access this webmail here, the web application. He will be redirected. First, he will try to access this service. He is not authenticated. He will be redirected to the discovery service, where he will select where his login is, which organization he's coming from. That means where the IDP is. He will access the IDP, authenticate here, and go back to the web application using the web redirect. What will happen is that this webmail will now say, okay, I know this user, you can access the service, but how to access this IMAP here? The IMAP doesn't speak SAML AI, so we must find a solution for that. What actually happens is, when the user is authenticated and accesses this service, the component, the AI component, the ship SP here, will actually open up a Kerberos ticket for this user. And it will do this in this way. First, it will access the KDC here. He will obtain the master ticket for this service here, because this service needs to have the master ticket because it will be representing the user to other services. It will obtain the identity of the user. Why does it need the identity? Because in the SAML AI space here, the user has a different username. He could be, for example, user X at uni, as in university.eu. But here, the local realm is org.eu. The Kerberos doesn't know anything about the usernames in the SAML AI side, which means we must have a sort of identity mapper. Something, a service that can map an external SAML AI username to an internal Kerberos username. Every user who has a webmail needs to have a local Unix account, for example, for this IMAP server here, so that the IMAP can serve and acquire the mail for it and serve the mails. And this is where the data is stored. The external SAML AI username, user X at uni.eu, and the Kerberos principal name, which for this user is user3.14 at org.eu. So when the user accesses this web application, the AI component, not the application doesn't see that. The AI component of the SAML AI side will create the ticket for the user, a service ticket. From the identity mapper, it will obtain which is the correct identity for this user and request the ticket from the KDC. And using this ticket, it can access either the IMAP server or SSH or something similar. For example, Cisco routers support Kerberos, which means if I wanted to have a looking glass application that accesses the routers and runs some show commands on the routers, you could use this kind of system to authenticate first the user using the SAML AI to access the looking glass, and then use Kerberos to access the Cisco routers using SSH, for example, and to run commands. And this system is much nicer than some predefined passwords or special usernames that don't require authentication, because the audit logs from these devices and servers show that the user 3.14 has accessed the service, not some general user which you can never really know who is hiding behind that. So you get pretty good audit logs and good accounting. Okay, so questions? Okay.
Yeah, I have one question to start the discussion. You had some problems to upload the videos. It might be that someone is interested in getting the videos as well. Just email to you and you will provide them, or are you not going to do that?
Yes, I will provide the videos. So if you're interested, please let me know.
I think it is really quite possible that that method that was developed in RNS can be used to a much broader service portfolio than Rock was just talking about. So if you have something in your home environment where you think you could use that, so talk to Rock. So, questions? Yes, please.
How do you provision the identities in the identity mapper? So how do you create the mapping? Do you have a service portal for that or something like that?
Yeah, exactly. This is a very good question. And yes, the first time that user accesses this web application and wants to have a service here, he needs to register. He needs to say, I want to open a mailbox. And this is when you get the mapping between this author identity, this SAML AI identity, and you create the Kerberos identity. So this is on our service page, yes.
So based on the attributes that are in the SAML assertion, you grant the user actually access to create an identity in your identity mapper.
Yes, exactly. He opens he can be, for example, from University A and access our service page and request to have, for example, John Doe at somethingelse.org open up for him. Okay. Next one?
Yeah, I assume one of the applications for this is that if we have a webmail and have the IMAP backend, so this is the web application we are thinking about. So I assume you had to write some plugins into your simple SAML installation, and there is actual code involved. Where can I get that code?
So can you repeat your question?
Where can I get that code you wrote for this?
It's available. You just mail me and I'll send it or put it on a public server. So it's inside Shibboleth SP 2.1, and it's using what we've actually added here in this Shibboleth SP is the code to access the KDC and to access this identity mapper.
Is it also implemented in Simple SAML PHP or?
It's not in Simple SAML PHP, but it's actually pretty easy to add it because it's very modular.
Okay, thanks.
Maybe. Depends on the interest, actually. One more question?
Sounds like you did this just primarily for IMAP, but you have SSH listed up there too. So just wondering what kind of web front end would you have for the SSH implementation of this solution?
This is just theoretical for now, but as I was saying, the looking glass would be a natural application that would need that. Because using the looking glass applications, when you want to get real-time data from the routers, like the BGP table, the networks, the trace route from that router, you would, for example, have the looking glass application here who would do an SSH over to the router using the Kerberos authentication, and then do a trace route from that and gather the output and return to the user here. So, but I don't imagine that there would be really a web application giving you a terminal to type things in. But you never know, maybe somebody would like to use that. It's possible. Okay.
Very good. Anything else? Yeah, there's another question.
I was just wondering, if you want to send mail, do you use IMAP as protocol, or do you have a similar trick in it with SMTP to send mail out?
Well, for the send mail, we're not using the authentication because the webmail here will just submit the mail. But you could authenticate, yes. We're not using it, but you could do that. Yeah.
Have you tried it with SMTP?
No.
Last chance? Okay.
Sold.
Let's thank again, Rock, for the very good presentation. So next speaker is Ravi Boots. David is working at the computer center at the University of Stuttgart. He was involved in a couple of quite nice projects like data loss and oh, it's a mic, yeah, my fault, my bad. And Akurimo, and we have also been in touch a little bit with EduGain at that time, but then he was working in Swift, and now it's a real nice idea he is presenting, especially if you are looking at upcoming Bologna procedures. That's quite an interesting idea, and I hope you enjoy this presentation as much as I was just before the meeting and looking through the slides. So, David, please, the floor is yours.
Okay. So I'm going to talk about payment in identity federations by using the example of how to charge a roaming student. And although I guess most of you will know the concept of identity federations, I will give a small example in the problem statement, then present. Sorry.
It's not safe. Let me just check what I can do here. Maybe it's just the other way around. So let's. No, that's not better. Are we doing something wrong? Okay.
Okay. So, well, after introducing the problem statement and why this talk may be interesting, I will present how the current established federations must be enhanced to support payment in that way that I'm presenting here. Afterwards, I will talk a bit about the security issues and go down to the protocol elements that may be used in the identity federations before I will finish with a conclusion. So the example I already was talking about is the student that study at the university, and in the good old days the student studies at the university and after some years he finished there, but now having the Bologna process, the student may move to another university, to University C, and finally he ends up at University D. And to avoid that the student who may want to have access to some e-learning platform or other restricted resources at the university, and to avoid that the student has to send all his data to that university, maybe some exam proofs from University B and C, the concept of identity federation can be used for that. So one of those universities acts as his identity provider, maybe the University A, where the student was at first time, and this university sends his attributes to all other universities. Well, for example, if here an e-learning platform is established and only students studying, for example, informatics may have access to it, then University A could provide the attribute that the student is studying informatics to University D. So here again in detail, the student wants to have access to some service provider, and the service provider gets all the required attributes from the Federation Cloud here. And this concept works really good, and identity federations are established in many countries now, but the problem is, what if the student does not want to access a service provider that has only a restricted resource, but a resource the student has to pay for example, a simple printer? Then, using the identity federation technology, this printer can try to access the student's identity provider and will maybe receive the attribute that the student studies informatics, but the printer won't get any money from the Federation Cloud. And well, this is not a new problem, how services at universities may be paid, so there exist some solutions so far. And the first one, the local payment account, that has been used when the student was only at one university. So it's very easy to handle. For example, there can be copy cards or some bank account locally. And well, when we think of roaming students, there's an administration overhead at the universities because they have to establish that solution for each roaming student too. And when the student in the example studies at 4 universities, then he has to follow the agreement to establish a local payment account 4 times. And maybe this is not good for roaming students. So the other possibility would be to establish a global solution like PayPal or credit cards. But again, this is easy to use for roaming students too, because it's not a big requirement to have something like a credit card or PayPal account. But now we have the administration overhead at the universities, because I don't think that universities will establish each printer access with a credit card interface. So maybe we should think of a third solution. And here the question is, when we have already established this identity federation concept, where we can get identity information from the user's home identity provider to his service provider, then why not using this for payment too? And this is a federation-based payment, where the payment solution is integrated into the federation or into the federation technology. And although this concept sounds good, it does not exist so far. But it may exist, so we have to look at first at the traditional federation architecture. What components are there? Usually we have the user, who wishes to have access to some restricted resources, and the user that has his or her identity information stored at his or her identity provider. We have the identity provider that authenticates the user, does the initial login, and sends the user's identity information to service providers. Then we have the service providers that are offering restricted services to authorized users and that request users' identity information at the identity provider. So what we can here see is that the identity provider provides identity information about the user to requesting service providers, and the question is maybe this a good concept to send payment information to the federation? And to do this, the concept of the federation architecture has to be enhanced by a fourth component, and this is the payment provider that acts similar to the identity provider, but now not transmitting identity information, but payment information. So the payment provider hosts the consumer's payment account in a similar way that the identity provider does with the consumer's identity account. And what a payment provider has to do is it must issue, validate, and reimburse payment statements. Well, some of the other members of the federation must be enhanced too, so the user, or in that concept it's also called consumer, has to have a payment account at the payment provider. And while at the identity provider nothing has to be changed, the service provider should accept those payment statements from the payment provider. And with these assumptions, the concept could be established. But before I'm going in detail to the processes, I would like to focus on the payment provider. And the payment provider, as said before, has to fulfill 3 tasks for a reliable payment solution. And this is the payment statement generation, the validation, and the reimbursement. So at first, when a consumer needs payment statements for some payment process, he or she has to come to the payment provider and ask for some payment statements, just for example, for €1 that is valid inside of the federation. And the payment provider must validate those statements whenever some federation participant that has some of those statements want to be sure about the validity of them. The payment provider must be able to validate these information. And for the third task is the reimbursement, for sure, because the service provider that has now a lot of payment statements received and may want to get money now for them to use outside of the federation. So the payment provider must then reimburse the payment statements into real money that could be used outside of the federation. And to do so, the payment provider has 4 main connections to the consumer for the statement generation than for the identity provider, because the consumer must be authenticated and maybe authorized during the statement generation process. And then to the service provider for statement validation and statement reimbursement. Well, for sure, some of those roles may skip, because if a consumer pays with a statement bearing too much money, then the service provider is now in the role of the consumer, and it has to request some payment statements maybe at his payment provider, and then they are sent, maybe sent to the user. Well, here's a structural example of a payment provider. We see that there are three different components. The first one is for the authentication of the users, the second one for the authorization, and only the third part is the difference to common service providers, where everything regarding payment is handled. So the task that generates the statement, that validates the statement, and that reimburses the statement. So this new block is brought into the federation concept. And to go a bit more in detail how the processes may be in detail, I would like to present the three processes: the issuing, the real payment, and the reimbursement now here with some sequence charts. The issuing could be done in that way that the consumer starts the request for payment data, and it transmits his or her authentication statement inside of this request. Just the common authentication data it has received, he or she has received during the initial login from the identity provider. Then the payment provider does the same than a common service provider would do. It requests, for example, attributes or validation of this authentication statement at the identity provider of the consumer. After that, the consumer is authorized, and here we may have some extensions like an account check. For example, is the account valid, or is a consumer maybe requesting more money than he or she has on this account? But if all checks are passed, the consumer may get a payment statement. And this payment statement may be used later for payment. So when the consumer accesses a service provider with a service request access, the request for service access, then the service provider may answer with a request for payment. The consumer sends now the payment statement to the service provider, and if the consumer does not have any statement at this step here, then the consumer has to have the statement issuing process now to carry out. Well, if the consumer has the payment statement, it sends it to the service provider, where we have here the statement check. Again, is it valid, contains it enough amount of money, and so on. And if the service provider needs statement validation at this point, then it contacts the payment provider that has issued the payment statement with a request for validation. The payment provider validates it and sends the validation information to the service provider. And if all checks are passed successfully, the service provider sends the access decision to the consumer. And the third process is the payment statement reimbursement. And here we have the service provider, for example, that has got some payment statements from the consumer in payment process before, and now the service provider sends a request for reimbursement to the payment provider that has issued the payment statement. And maybe the service provider must be authenticated too, and in that case, the payment provider contacts the identity provider of the service provider, but that's only an additional step. After that, the payment provider validates the statement, and if the validation process ends with a successful result, it reimburses the statement by marking it as invalid and by transferring money to the service provider's account. And after that, the service provider is informed here about the result of the reimbursement. Well, when speaking about payment, we must focus on security, and for sure there are lots of general attacks against the infrastructure and communication, like man in the middle, DOS, eavesdropping, and so on. But those are not in the focus of this work. And when thinking of identity federation, the language SAML pops up, so there may be attacks against SAML if SAML is used. So there is already done work about attacks against SAML in general by Hirsch, Philpott, and Mahler. So there's also no goal of this talk to go in detail into the general attacks against SAML, but those who are very important for the payment issue is the overspending and the data tampering. At first, the overspending, if I am a consumer and I have some payment statements, why not issuing or transmitting it to more than one service provider? That would double my money. And another way, the data tampering, if I have a statement for €1, then I can add some numbers and suddenly I have a statement that's valid for €100. So the overspending as well as the data tampering must be avoided. And there exists some security solutions. The first is the hardware-based solution, where we can say each federation participant needs secured hardware, for example, a secured USB stick. And this hardware controls the handling of the payment statement. So the application that sends and receives payment statements is signed with the signature of the issuer of that payment application, and the payment or the secured hardware checks at first this signature, and only if the signature is still valid, the application can handle the payment statement, and afterwards the secured hardware signs the payment statement. So when I am the receiver of such a hardware-secured payment statement, at first I must check if the signature of this payment statement is valid and it is signed by a secured hardware. And in that way, overspending as well as data tampering may be avoided. Because overspending would, when I would overspend some data, then the payment application would detect it, and the payment application won't transmit those data anymore. And if I change the application, then the signature of the payment application would become invalid, and then this tampering would be detected too. And in the same way, I cannot tamper with the data. So this brings high security to the payment approach, but with the disadvantage of having the requirement of some securing hardware. So whenever a participant wants to join the federation, she must use this hardware, and when I upgrade the federation protocols or other elements of the federation, then maybe the hardware must be exchanged. And then, if this is not wanted, we can choose the software-based solution that works in a similar way, like the validation of the identity information that are transmitted from the identity provider to the federation. So when issuing the payment statement, the payment provider stores some information about the payment statement. And when the consumer pays, the service provider receives this payment statement and requests directly a payment statement validation at the payment provider. The payment provider gets the request for payment statement, and this may be seen as a proof for payment. Because if any other entity within the federation requests the payment statement validation, then the payment statement must be transmitted from the consumer to the other entity. And so the payment provider knows now this payment statement has been used for payment, and if it's the first time, then it is still valid. But at any other time, at any other times, the payment provider will receive this request for validation. The payment provider will detect that this payment statement was already used for payment. And with this check, all the two processes, the payment and the reimbursement, may be done, secured, but without having the requirement to use additional hardware. But the reimbursement works in the same way, that the payment provider validates the payment statement, and if the statement has not been reimbursed before, then it will be reimbursed and marked afterwards as being reimbursed, so it won't be reimbursed anymore. If there's a high level of trust between the service provider and the consumer and other entities within the federation, we can choose a weak software solution where the service provider requests no direct validation. Only when the payment provider receives a request for reimbursement, the payment statement will be marked as reimbursed. For both processes, or for both security solutions, a lot of information is needed, and unfortunately it's very small here, but you may see that both solutions are using some of the information in parallel. For example, the amount, the currency, and the payment provider ID must be transmitted in both security solutions. The hardware-based solution needs an additional secured hardware signature, a payment data ID, and a payment data lifetime, while the software-based solution needs an additional signature of the payment provider, the ID and the signature of the payer, and, as here mentioned before, payment data ID and payment data lifetime. And all those information should be transmitted within the federation. And when I said in the beginning, it would be good to use the federation protocol and its language, then we must now focus on SAML, because this is used in many identity federations. And some SAML elements is the request and the response, and this response can contain assertions, and the assertions can contain statements. So for transmitting some of the payment information, it can be chosen to have an attribute statement with some payment information, or to create a new statement called payment statement that's then included in an assertion. And an example how this may look like is here. It's just a SAML response. So it has an ID, and it's in response to a request, and the request has this ID, it's version 2.0. Here we have the SAML payment assertion, it's called, and in that way it has been chosen to have a new statement, the SAML payment statement, where the information 2.5a for the amount and the information 0 as value for the attribute currency are transmitted. And the information that are required by the hardware or by the software approach could be found here in the example. I've listed it here: the amount, the currency, payment provider ID, hardware signature, payment data ID, and payment data lifetime for the hardware approach may be found in the lines of the example. So every one of you who is interested in may download the slides or the accordant paper, and then you may check if it's really so. But for example, the payment data ID should be stated in line 21 of the example, and line 21 is the ID of the payment assertion, so it should be okay when we choose the payment data ID as the payment assertion ID. Well, coming to the conclusion, I have to say that currently we are missing an integrated payment solution for identity federations. And although many federations are working really well now, this is a problem when I want to offer micropayment like paper, printers inside of the federation. And those federations are often established in academic context. So without having some payment solution, it's a little attractive for commercial service providers, especially for some small service providers. So it would be a great idea that an identity federation could be used also at the local copy shop. But I won't get more than the attribute. This customer is a student. And so I need, for the local copy shop, a local payment solution. But if my federation would support payment, then this federation would become really attractive for commercial service providers. And then the federation in general would be more attractive for consumers. The solution, or one of the solutions, could be payment over SAML, which is where we have not only transmitted, or where we have not only the transmission of payment information via SAML, but in the hardware approach, we can use those information directly for paying later, so they don't have to be exchanged. It could be very high secure. When using the secured hardware solution, we could have a strong software solution or a weak software security solution, and all those could be happen with only a few modifications of the federation and the protocol. So that's all from my side. If you have any questions, please ask.
I think that's a nice idea. It might be a little bit complicated for these small payments that probably are the background for that. So I was thinking, if you just park your car in a lot and you just can pay with your mobile phone for that. That is something that the student has today. So it might be another option that you did not mention so. But I guess nevertheless to have the SAML extended to that kind of purposes is probably quite interesting, I think. Any questions? I have one more. Students are often short of money. So what happens if the reimbursement statement cannot be fulfilled because there is no money left for that student?
And that depends on the kind of security solution that has been chosen inside of the federation. If we are using the hardware solution or the strong security solution, then the payment statement wouldn't be issued if the student has not enough money. In the weak security solution, then it's the opposite. The charging of the consumer's account would happen at the end. And if the student has not any money on his or her account, and the student is still in the federation, and then the payment provider could inform the student about that he or she has to give some money to the payment provider. But that's a real problem if the student left the federation at this time, going back to his home country where the federation is not active, and then it depends on the federation if the payment provider or the service provider will lose the money.
So we need to confederate these things. Yes, there's a question, George, please.
I was kind of wondering who you see being in charge of the money in this, whether it would be the university themselves or a trusted third party for the federation.
Pardon? I haven't got the question.
I was wondering who you'd see as holding the students' money, whether it should be an institution such as a university or a third party that's acting as a bank for the entire federation.
So I guess the question is the same as who is the payment provider inside of the federation.
Yes.
And but in general, the payment provider could be every institution who is accepted by the federation members or has signed the federation agreement with the federation manager. The two possible solutions that come a bit more to the real world is that the payment provider is either the student's university or combined with the student's identity provider, or And that would be a good goal when thinking of a long time. If really bank institutions could join the federation, and then it would be really good to have those banking institutes as payment providers.
Okay, thank you. More questions to David? If not, then let us thank him again. There's one question from Andrew.
Could I quickly ask those in the room, those on the street can't help, probably can't hear either, could you check under the desks and see if there's a handbag that isn't yours?
Jo. Prima gemacht. Danke dir. So that brings us to the last presentation in our Virtual People session today. It is Ville Tenhunen, and I think he was working with Juha Ojaluoma together. Ville is working in the IT department of the University of Helsinki, and we are now on more on the mobile area. The item Ville is talking about is mobile signature services, authentication, and profile distribution. And please stay patient. It's not so far that we can conclude the session. Ville, please, the floor is yours. Do you want that mic port?
Yes, thank you. Maybe I try that one, because it's my bad habit to run a little bit.
Should work, so.
Okay, hello world. All right. Okay, the last theme of the last session or last presentation is mobile signature services and authentication and profile distribution, and I will tell you about our project which we have had in okay. What? Okay. Oh. Now I hear something. Okay. Theme was mobile signature services and authentication and profile distribution, and I will tell you about our project, which we have had in University of Helsinki within last year and beginning of this year. And I will tell you about technology and, of course, then some legal issues and other things. And now we can...
You can use the mouse, it's easier.
Oh.
I was disturbed.
Okay, may I? Now, technology is wonderful. And content of the presentation, shortly, some words about our working environment, that you can get some numbers or figures, where we work and what kind of identity questions we have to solve in our infrastructure. And then about some words about this project, and then of course the technology, which is the behind of the system, and few words about legal and administrative aspects which are quite acute right now in Finland, and then some possible ideas how to use this technology in the future and what we found. And I worked in this project as a project manager, and here is Mr. Juha Ojaluoma also, who knows those technological details better than I do. So if there is these very hacking questions, so then I ask you how to answer them. Okay, University of Helsinki in brief. Well, the most important things are those numbers that we have about 35 degree students, and This 47,000, it's a combined number of degree students and open university students. There is both roles included in this number. Then we have about 8,000 employees, and in our network there is 51,000 user accounts. It's not a huge number in global aspect, but in Finnish aspect it's quite big, because if we are going to renew our intranet, we are going to do the biggest intranet in Finland. Okay, then maybe some interesting numbers are this establishing year, because University of Helsinki is oldest and biggest and the most beautiful university in Finland. Yeah, I'm very sure about that. Okay, the project. The goal was the research, this mobile signature service technology and in its possibilities and advantages in our infrastructure, and find out what kind of obstacles or problems, laws and administrative rules and stuff like that state to us. Then we made a pilot system where we had a few things, and we created this kind of user account service which used this MSS technology, and in the proof of concept level we check out this profile distribution. And in this project we had a cooperation company called Methics, and they have a technology, Kiuru technology. It's their product, and we use that product in server side. What is the mobile signature service? Beginning of this technology is European Parliament directive about digital signatures, and it used those European Telecommunications Standard Institute standards, ETSI 204 and 207, these ones. And we can use this mobile signature to strong authentication. I have these papers, I don't use them, but I have to have them because I have some notes maybe there. The main we can use to strong authentication and delivering digital signatures in mobile networks. Mobile signature services can be used by mobile phones, PDAs, or any device which use mobile network and is able to store these PKI credentials and software to use them. It's quite easy to use, and those needs are not very big ones. Possible services which we have found in university level is strong authentication of students or employees or anybody else, and for example logging with the Shibboleth service. One critical thing is for us is a password change service, that people forget their passwords, and we would like to automate this service. We have this kind of automatic service already, but we thought that maybe this mobile strong authentication is possible to use in this sector. Of course, user account activation is one thing where people have to go somewhere and show their passports or driving licenses and have this kind of strong authentication and then get a user accounts. It's possible to create automate systems for this activation process. Of course, there is this strong authentication of administrators if you had to go some critical server and use VPN connection. So maybe it's a wise idea to know who these persons really are. And the distribution of user profiles, this is a little bit new idea. And for example, if we have to give to the banks some certifications that someone is a really student of University of Helsinki, it's possible to create almost automatic process for that also. This is just one example. This profiles can include number of different information and so on. This MSS services can be used in any services where you need strong authentication or digital signatures. Okay, this is the way it mainly works. So everything starts, as a matter of fact, from here. That you have user have to get SIM card, which have this certificate properties. And okay, teleoperators in Finland, they like to deliver these SIMs because it's a business of these teleoperators. And then user have this mobile phone SIM card and possibility to register this network identity. And then this registrar is in, okay, this slide is a little bit, how can I say, unreal or wishware or something, because this kind of situation doesn't exist in Finland right now, but this could be future solution to create this process. Okay, after user have get this mobile phone and SIM card and so on, you have to register your his or her identity via register, which could be in current situation a bank or teleoperator or maybe police. It could be it have to be some organization or some place which this certificate authority can trust. And this certificate authority, it plans to be teleoperators or some kind of community of teleoperators or something else. They can use some information in checking processes from our people register center, which have these personal identity codes of all of the people and all of the Finnish citizens and so on. And there could be some kind of checking process. And after user had registered his identity and or this certification or SIM card, he can use those services, for example, banks or university or any other else who had which have communicating this MSSP, mobile signature service provider services, operated by some teleoperator. What are these transactions in use? And here we have this this first line, which is the user, application provider, for example, the bank or someone else, and home MSSP, which is more normally operated by some teleoperator, but it could be someone else also. And the process starting that this user would take a contact to the application provider. And application provider, and he asks to activate authentication or signature process. And after that, application provider tells that, okay, let's do it. And now we are starting the process, and then application provider take a contact to the mobile signature service with starting the process. After that, this mobile signature service provider asks straight from the user this information and pins, and ask to authenticate to the system, and in number 8, the user's mobile device sends this information to the home MSP, which checks that everything is okay and authentication process can go on. And if everything is okay, this MSP inform the application provider that, okay, this person is he or her, he tells to be. And then application provider says that, okay, now you can use your bank account or whatever it is. And here in another picture, here is some remarkable thing, that this service or the point of this service application provider could be, for example, web service. It could be normal personal desktop service, like a travel agency or something else. It could be telephone or anything else. But all the time, this authentication or signatures goes and comes in different channel. There is this kind of 2 channels that you have here. These services and applications, and the authentications and so on goes to the home MSP via mobile network. And how it looks to normal user. This first picture is the authentication request. Authentication request and gives the information that what is the service, and what he or her have to do to continue. And it's in this segment, it's here number 3. As a matter of fact, and the remarkable thing is that here is the code which identify, for example, document which he or her is going to sign, and it can be used for that. And okay, user just press OK and go on. And the next one is entering the PIN code, and now we have to remember that this PIN code is not the same PIN code than the SIM card's PIN code, because this is a security PIN code and it's only known by the user, and user can change all the time this PIN code. This is different than normal mobile phone's PIN code, and this comes from in this process is here. And the third one is from the end of the process, from 12, and it gives the information that, okay, now this service or authentication or signature is okay, and everything can go on. It's so easy for user, normal user. There is only for this kind of three situation when he or her have to look the mobile phone and do something, and everything goes on. And then, of course, there is those services, for example, in web, which he have to do, and so on. Okay, user account activation service, which we have made. This is not a very clear picture, but well, here is a 2 situation. This one is existing and current situation, where we have this TUPAS, and TUPAS is a strong authentication method operating by Finnish banks, and it's based on this kind of single-used codes and so on. This is an electronic identity card, this ESG. And Vetuma is it's this kind of authentication service bought by Finnish state. And when user uses this service, it gives to the application, and in this case, user account service, it gives this personal identity code. It's this kind of normal one. And here, this our system used this kind of SATU, which is the electronic personal identity code, and it's connected by this real one. And this is the public information. And in our setup, we took this connection from the user, and then we mapped with the population register center system where this kind of map and we saved those personal identity codes into our databases, because we know our students and we have this personal identity information. Okay, next slide tells that something about cooperation of Shibboleth and JAS, and it means that if, for example, University of Helsinki have this MSSP acquiring entity, which is the part of the system, it's possible that via this JAS module is connecting, for example, another IDP of another university to our MSSP, which communicates via mesh, which is the routing network, to anywhere else. And we can use, for example, Finnish universities can use only one ASP service and create this kind of strong authentication methods for every university. But it could be also something really else, for example, OpenID. Profile distribution, few words about profile distribution, and the basic idea is that student would like to have student certificate, and he's starting from the bank application. This is a fake name, this Fiktiivi Pankki, but student start the process and give the consent, and then this MSSP asks from MSSP of University of Helsinki that it could be possible to get student certification from University of Helsinki, and then if it's possible, here is the authentication information with delivers here, and we can automatically send this information as a SAML message to the bank, and then bank knows that okay, this person is a really student of University of Helsinki, and bank can get, for example, student loan. Okay, this picture is not very clear, but these teleoperators are in remarkable roles because they are managing this MSS mesh, and this information transport goes via that way. Okay, a few words about legislation and administration. There is in Finland some need for legislative basis to define responsibilities and roles, and currently there is in our parliament is a new law, Act on what is it in English? Act on strong authentication and digital signatures. And it's possible that it will be accepted in this summer, but it's possible that it will be delayed some little bit later. But probably within this year we will have new law for that, and it gives the basis for teleoperators to create these kind of services, and they can sell sell those SIMs and they can sell this backbone infrastructure for organization and so on. Of course, we have a number of different rules also, but main finding was that if number of problems we can avoid if we are taking account those user consents. And for example, in this bank example, the main player was this user who started the process. Without this user's consent, doesn't happen anything. But when we go that way, it helps in number of legal problems. Okay, last slide. Conclusions. We find out that technology is mature enough. It's easy to use, and it's easy for users. It's easy to use in a server level, and it's a potential method to replace current strong authentication methods in the future. It's very easy to integrate, for example, SIP-less services or any other kind of applications. And it doesn't need very big projects or something like that. Usability, it's important in number of cases, and here it's in high level. In high level. Problems are delivering those certificate SIMs and organize this registration process. This registration is the key in number of questions, because there is this user and the system connecting first time, and then the authentication in this situation is the most remarkable point of the service. So cost, we don't know how much this cost, but okay, it will be clear when teleoperators tells that how much it costs. But we believe that this could be one solution in area of strong authentication in the future, but of course we don't know yet. And some thanks for the guys in Methics Limited and in our university. But that's it.
Thank you. I think it's a nice project. So if it's really flies, and you just have a kind of smart card service without real smart cards and smart card readers, just you have to involve, of course, all the operators in between. Any questions to Ville? Oh yes, we have two of them. You start first row and then you. Okay.
I didn't quite understand. On one of the first slides, you showed who the registrar and who the trusted third party were. Did I understand correctly that the trusted third party who issues the certificates, that it is the mobile operator in your case?
You mean? Wait a second. You mean that one?
The CA. You mentioned teleoperator. Do you mean by that is the mobile operator, so that the telco is the one who is the trusted third party who is issuing the certificates?
Yeah. This could be so. It could be. Probably it goes that way, that there is some kind of coalition of the teleoperators and banks, a number of different players.
Okay.
But because, and in Finland we have this people registration center, which is currently also the certification authority, for example, passports and driving licenses.
So it's the government who is issuing...
Pardon?
So it's actually a government organization?
Yeah. This is an official organization. It's a part of the Finnish state organization.
Okay. And does that mean that the certificates that they issue, are they qualified certificates according to the EU signature directive? Or
yeah.
With a face-to-face check, and you can use them to replace handwritten signatures as well?
Yeah. If this is not as strong as it as strong as possible if there is something, for example, teleoperators or something. And this process could be face-to-face process, but possibly it could be automatic process if you have had some strong authentication method already, for example, TUPAS or this identity card or something like that. Okay, this is not the strongest possible, and if there is a, for example, okay, if here is a police or some official operator here as a registrar, then it could be stronger than this commercial solution. But in Finland it's a little bit problematic create the commercial solution, because then there is 2 steps in this registration process, and it's too much for the users, because users don't first buy SIM, and then they have to go to the police office, and then they have to go somewhere else and wait and wait and wait and so on. It's too many steps for the commercial success, I think.
Yeah. Can I ask one more question? Yes. I saw that you use it to provision accounts for users. So I'm assuming that this is a service that people already have on their phone, and you're using it to issue account information to people. Do you also plan to use it as an authentication method on its own? Because for web services, you could authenticate using this instead of having a username and password, and this is much stronger.
Yeah.
Do you use that as well?
Passwords?
No. Do you use this instead of having username and password to authenticate to web services? Because
No. We are not going to replace passwords in University of Helsinki with that, because this costs much more than this password system, and its passwords are so easy. And normally, in normal cases, the passwords are enough for us. But if there is any kind of agreement you have to do, then we need a little bit stronger authentication than these passwords. And there is these cases where we need strong authentication, but not everything, because okay, passwords are so easy to use and so on. But for example, when users forget their passwords and would like to change that, then we need some strong authentication in any case.
Yeah, thank you.
As usual, I think it is a matter of how many are using this. So if it is really in operation and many are going to use it, then of course it's getting cheaper. And I guess you can just bind in your normal PKI for getting the certificate from there. So the procedures seem to allow this, in my opinion. So next question.
Hello, I'm from Estonia, and as a comment to the last question, we already have this in Estonia working. We have one mobile operator who is acting as the registrar and MSSP, and second CA who is not a government organization but working with government, and that is a coalition of the banks and mobile operators. And this works quite well, and we in ENET, we use this as authentication method for web services currently. Because it's simple for us, because a small company made an OpenID provider based on this. So we just implemented OpenID and got strong authentication with mobile ID or ID card. So, but my question was that can you comment on the signature part of this scheme? How is in Finland it's planned? Is it legally equal to regular signature on paper? And how can the users trust the document that they're going to sign?
Okay, this might be a little bit. Okay, let's check if there is, if it's a technical situation. But for example, here is this. Do you mean this code?
Yes.
Okay. This code this goes that way, that it gives the unique code in the signature process, and the same code is included in the document which this in the service which the person is going to sign on. So here the user can check what he is going to do seriously.
But actually the user is, I think, signing some MD5 hash or something like that of the document.
Yeah.
Not actually that for digits over there. So the user doesn't see the right thing that it's going to sign. So how can he trust that the teleoperator sent him the right hash that you on the web server sent to the teleoperator?
Okay, my colleague Juha have an answer for that.
Juha, please.
Okay, the digital signing is totally different case, and there's another PIN code for that. And if we will do the digital signing, there will be one screen more, and the mobile phone will show you the hash code, which is calculated from the document. And for the user to be sure about the document, he has to download it and calculate the hash code by himself, so he can compare and be sure about the correct document. But we didn't implement this, obviously, because it's kind of difficult process for any user to do, so we would have to have own service which do this for the user. But that would be the case. Did this answer the question?
Yeah, this is okay. This picture is for authentication, and in signing there is one more that way.
If I may just comment on to close it, in Estonia we have both the authentication and the digital signature with two certificates, two different PIN codes in one SIM card. So I personally use it for my banking. I first authenticate with the first PIN code, and then for a transaction I digital sign it with the second PIN code. And I'm a bit worried about what the thing is that I'm signing, because our service doesn't show the hash for me on the mobile screen.
Yeah, that's true that this is a very critical point. In Finland, it's also the process goes that way, that for authentication here is a one PIN code, and it's another for signing something. There's a two, and this is was it 4 to 6 digits, and the signing was from 6 to 8 or something. I don't remember those number of digits, but anyway, there is two different codes.
I do not want to stop the discussion, of course, but you should just go in touch and get your information.
We can discuss about it later.
Last question, please. One remark. Can we have the mic, please, for a moment?
I think, just to answer your concern, the EU Signature Directive states that what you see is what you sign. So if you don't see a hash code or anything that allows you to determine what you are signing, then they haven't implemented it correctly. But actually, it's very difficult to explain to users that what you see is what you sign, you have to check hash code. My father is not going to understand that, and my grandmother is certainly not going to understand it. So you have to have some way of showing the user what they are signing, and that's still a big issue. So I think this kind of service is very strong for authentication, but for actually legally signing documents, it's very hard to explain to the user what they are doing.
Yeah, there's an acceptance problem, finally. Yeah. Okay, let's thank Ville and Juha again, and you all for your patience and for the good discussion. This concludes our session, and just get the bus to the hotel and be in time for the social event, and see you there then today in the evening. Thank you.